Hi there, and welcome to today's class. For today's mathematics class, we'll be considering the multiplication and division of surd. So last class we have discussed about the addition and subtraction of surd, and also the rules that govern surd. If you're interested in watching our last class on surd, simply click on the link you see below. Sorry, above. All right, let's dive into today's concept. For this class, we're talking about the multiplication and also the division of surds. So how do you multiply surd? How do you divide surd? Let's start with the first one called multiplication of surd. What's the concept behind multiplying two surds? When it comes to addition, I gave you what to note. Two surd can add if they are of the same if they are of similar surd, or if they are of the same root. I said that in last class, and I said that two or more surd can also subtract if they are also of what, of the same root or of similar surds. So now when how do you multiply surds? So what's the key concept to note when multiplying two surds? So note that two or more surd can multiply if they are of either similar or not similar surd. So if they are similar or they're not similar, they can multiply. So when it comes to addition, they must be of similar surd. But when it comes to multiplication, either similar or not, they can what? They can multiply. So that's the concept behind multiplication of surds. So let's take a quick example to further explain the concept behind multiplication of surds. So let's take this example here. Example. Evaluate the following. All right, let's get this done. Number one, I'm given that root 2 multiplying 5 plus root 3. Number 2, I'm given that root 2 plus root 5 into root 3 plus 6. All right, finally, let's take one more example. I have root 11 plus root 7 all squared. All right, let's get this done. So let's say we are told to evaluate this question here. So how do you solve this? How do you multiply these surds? So first is first, we said when multiplying surd, they might be of similar or not. So either they are similar or not similar. That's it. What do we mean by similar surds? If I have, let's say I have 2 root 3 and I have 4 root 3. These are similar. Why? Because they have what? Similar surds. Root 3. If I have 2 root 5 and I have 2 root, let's say 10 root 6. These are not what? Are not similar. Why? This is root 6, root 5. They are not similar. So when it comes to multiplying surd, either they are similar or they're not similar, they can multiply. That's the concept. So how do you multiply this given surd here? Let's get this done. Solution number one there. Solution number one, I'm having root 2 into 5 plus root 3. Let's get this done. My first task says that I'll use this root 2 to expand through this bracket here. So what do I get? Using root 2 to expand through, root 2 times 5 will give what there? We give 5 root 2. Root 2 plus root 3, that gives plus root 6. 2 times 3 will give 6. Then you ensure that the 2 are, if I have root 2 times root 3, this can be written as root 2 times 3 which give what? Root 6. So the idea is that I assume you should know this concept. So root 2 times 5 will give 5 root 2, not root 2 5. I'm saying root 2 times 5. Root 2 times 5 will give what? The 5 root 2. Not, we give this, but not what? The root 2 5. This is wrong. This is the correct one. So the number comes first before the what? You use this root of that number at the back. All right, this becomes my answer after simplifying this question here. So if I expand this through here, I'll have this as my answer. This is like the idea behind multiplication of sorts. Let's take example 2 to further explain the concept behind example 2. Example 2 says I'm having root 2 plus root 5 multiplying root 3 plus 6. How do you do this? How do you expand this? My task here is to apply the concept of binomial theorem. If you don't know how to expand, or how to how to expand two brackets using the idea of binomial theorem, I'll drop the link to binomial theorem as you can see above. I'll drop the link above, so you can click on the link you see above the video, then it take you to the page on how to expand term using the idea of binomial theorem. So my first task, for teaching sake here, my first task is to expand through. How do I expand? I'll pick out the first term here, that's root 2, multiply by everything here, that's root 3 plus 6. My next task here now is to pick out the second term plus root 5. I just pick out root 2. Next, to pick out root 5 plus root 5 into everything here again, root 3 plus 6. Let's multiply through. If I multiply through, root 2 times root 3 will give root 6 plus root 2 times 6 will give 6 root 2. All right, proceeding, plus root 5 times root 3 will give root 15 plus will give plus root 5 times root times 6 will give 6 root 5. All right, at this point here, what's my next task? My next task is to observe, is there any similar sort there that I can add? This is root 6. So this is root 2, root 15, root 5. So they are not similar, so they cannot add. So it becomes what? My answer to that question there. So let's say this is 6 root 5. Let's say there's 5 here now. Let's say if I put 5 here now. So it means that this one and this can add, but it is 2. So they're not similar. So this is my answer to that question there. Let's do number 3. Number 3 there. Number 3 says, if I have the square root of 11 plus root 7 all squared. So from the idea of indices, from the idea of index, if I have a raised to power 2, this means what? A times a, which will give a squared. The twice of what I'm having here. So it means for this one now, the expansion of this becomes root 11 plus root 7 multiplying root 11 plus root 7. That's the meaning of this question here. So apply the same concept I use here to this one here. My first priority is to pick out the first term here. That's root 11 into everything here. Root 11 plus root 7. Next task is to pick out plus root 7 into everything here. Root 11 plus root 7. At this point here, what's your next task? Next task is to expand through. So root 11 times root 11 will give root 121, if I'm correct. Next up there, I'm seeing a plus sign, plus root 11 times 7 will give root 77. So plus root 7 times 11 will give root 77. All right, plus is plus. Root 7 times root 7 will give root 49. Or perhaps root 7 times root 7 will give 7. you should know why this is this. Now we said from the basic rule of sort, we said if I have root a multiplying root a, that becomes a. And I prove this to you. So it means that if I'm having root 7 multiplying root 7, that will give what? The 7. No stress. No stress. All right, at this point here, what's your next task? Of course, from here now, I can see that I'll be having root, and of course again, look up, of course again, I'm seeing root 11 times root 11. That will give what? Just 11. Instead of wasting my time, that will give what? 11. So at this point here, I'm seeing 11 and I'm seeing 7. So if they are like, these are whole numbers, 7 and 11, I can combine them together, right? So that will be, if I combine 11 plus 7, I'll have 18. So I'll have 18 plus root 77 plus root 77. So if in mathematics, look up please, if I have a plus a, that's give what there, that will give 2a. Observe the difference between a times a, we give a squared. A plus a will give 2 of a. So I'm saying root 77 plus 77, that will give what? 2 root 77. So I'll have 18 plus 2 root 77 as my final answer to this question here. So this is how to solve these problems here under multiplication of sorts. Let's dive into division of sorts. How do you divide sorts? So let's discuss division of sorts. Division of sort. How do you divide sorts? All right. So here is what you need to note when it comes to dividing two sorts. So to divide any two sort, simply rationalize. So that's all. So what you need to note when it comes to division of sort is that to divide any two sort, simply what they simply rationalize. All right. Before we dive into the concept of rationalization, let's discuss two important key concepts when it comes to division of sort. When it comes to division of sort, we're going to discuss number one, the conjugate of surds. The second thing is what? Rationalization. So when it comes to division of sort, two key terms you need to note. Number one, there is what? Conjugate of sort. Number two is called rationalization. Let's discuss the first one there. Number one there, conjugate of sorts. What's the idea behind conjugate of sorts? The idea is simple. Let's say I'm given a sort A to be equal to 2 plus root 3. Let's say I'm given a sort A to be equal to what? 2 plus root 3. The conjugate of the sort, so the conjugate of this sort becomes 2 minus root 3. When it comes to conjugate, the idea is just change the sign. That's all. I'm given that a sort is given as 2 plus root 3. What's the conjugate of that sort? Becomes 2 minus root 3. So when it comes to conjugates, it's like change the sign. So let's say I have let's say I have root 2 plus root 5. I have root 2 plus root 5. What's the conjugate? Becomes root what? Root 2 minus root 5. So when it comes to conjugates, the idea there is what? Change the sign of the what's it called? Of the change the sign between the number and root, or a root and a root. That's the concept. Just change the sign, you're off. That's the concept behind conjugates. Let's discuss the next concept called rationalization. What's the concept behind rationalization? When it comes to rationalization, the idea is that in mathematics, purely math, it's not proper to leave your answer, your denominator, as a square root. Let's say I have solved a problem. I solve a problem. I solve a problem here, and solve a problem N. And I end up my answer, I'm having root A over root B. Let's say I'm having root A over root B, for instance. I can't call this one my answer. So this is not correct. So far I have solved 3 pages and I end up this one as my answer. I can't mark this correctly for you. This is wrong. So in mathematics, it's not proper for you to leave your denominator as a what? As a square root. So to avoid leaving the denominator as a square root, what you do there? You rationalize. So I'm saying that to avoid leaving your denominator as a square root, so what do you do there? You rationalize. So when it comes to rationalization, there are 2 key concepts there. We have for the simple form and the complex form. So when it comes to this man here, we have for the simple form and we have for the what? The complex form. So when it comes to rationalization, there are simple form and what? Complex form. Let's call the simple form. For simple form, what's the idea? The idea is quite simple. The idea is that, let's say I have root A all over root B. Something of this case here. That's what this one here I gave you is for simple form. So for simple form here, how do you erect this root? How do you change it so that you don't have root at denominator? The task is what? Rationalize. So for simple form, just multiply numerator and denominator by what? By denominator. That's root B all over root B. Multiply these two here by this man here. Now we don't want it to be a square root. Multiply it by it. So it means that root A times root B will give root AB all over root B times root B will give B. Of course, we said root 11 times root 11 will give 11. Root 7 times 7 will give root 7 times root 7 will give 7. Root B times root B will give B. This becomes my answer. Observe that my final answer, I'm not having a square root at denominator, so I've what? Rationalized. That's the concept behind simple form of rationalization. Let's call the second one. They're called the complex form. For the complex form of rationalization, the idea is that let's say I have root A all over root B plus root C. For this one, although this one is more complex. For this simple form here, just multiply the 2 of them by what? This one here. So how do you solve this one? This is complex. So the idea is still the same thing. Multiply numerator and denominator by the what? The conjugates. Now this one is just a single root. This one here consists of what? 2 roots with a sign in between them. So my idea is that I'll now apply the concept of what? Conjugates here. So multiply numerator and denominator by the what? By the conjugate of denominator. For this one here, the conjugate becomes root B minus root C all over root B minus root C. That's the concept behind this one here. Multiply numerator and denominator by the conjugate of what? Denominator. Change the sign to what? Minus minus. Welcome back. I want to understand the concept behind simple form of and complex form of rationalization. Let's take a quick example under the division of Surds. So let's say we are told to simplify this one here. So we're going to evaluate these 2 here. So let's get it done. Solution. For number 1 there, number 1, I have root 2 all over root 11. For this one here, it becomes the idea of what? Of simple form of rationalization. So we said multiply this one here by what? Denominator over root 11. So we said the idea is that it's not proper for the denominator to be square root. So what you did, it was apply the constant of this man. So now multiply the 2 by what? Denominator, as we said earlier here. So it means that I'll have root 2 times 11 will give 22 all over root 11 times root 11 will give what? 11. It becomes my answer after solving this one here. Let's say number 2 done. Number 2 says, number 2, I have root 3 plus root 2, sorry, plus 2 per se, all over root 2 plus root 7. Alright, let's get this done. So this one becomes a concept behind what? The complex form of rationalization. So how do you handle this one here? We said the idea is what? Multiply the 2, this 2 here by what? The conjugate of denominator. So this one here becomes, the conjugate of this one becomes root 2 minus root 7 all over root 2 minus root 7, right? So I'll encase them in the brackets. I want to combine these two together. I'll have root 3 plus 2 multiplying root 2 minus root 7 all over, combine these two, root 2 plus root 7 multiplying root 2 minus root 7. Alright, let's handle this one after the other. Let's expand numerator separately and expand denominator separately. Expanding numerator, what do I get? The idea behind expansion, pick out the first term, root 3, into everything here, that's root 2 minus root 7. I'm done. Second term is plus 2 into, plus 2, this plus 2 here, into everything here, root 2 minus root 7. I'm done with this one here. So all over denominator, I have root 2 first, root 2 into everything here, root 2 minus root 7. This is plus root 7 into what? Root 2 minus root 7. Alright, proceed from here. What do I get? Root 2 times root 3 times root 2 will give root 6 here, minus root 3 times root 7 will give root 21. This is a plus sign, plus 2 times root 2 will give 2 root 2, plus minus will give minus, 2 times root 7 will give 2 root 7. I'm done with numerator. Let's get the denominator. Root 2 times root 2 will give 2. Yes. Root b times root b will give b. Of course, root 2 times root 2 will give 2. Minus root 2 times root 7 will give root 14. Plus root 7 times root 2 will give root 14. Plus minus is minus. Root 7 times root 7 will give 7. Alright, let's get this done. Okay, what do I get? Let's get them all done. So at this point here, what do I get? Alright, I'm having what's it called? At this point here, I'm having root 6. Root 6 minus what's it called? Root 21. Next up, plus 2 root 3. 2 root 2. 2 root 2. This one here. Minus 2 root 7. So all over. Observe that minus root 14 plus root 14 we cancel out. So minus 1 plus 1, that's 0. So minus 14 plus 14, that's 0. Left with what? 2 minus 7. I read about 2 minus 7. At this point here, I'll get my value here. I'll be having root 6 minus root 21 plus 2 root 2. Alright. Minus 2 root 7 all over 2 minus 7 will give, that should be around minus 5. So I'm correct. Alright. -5. In mathematics, it's not proper for minus to be what? A denominator. So what's the idea? I'll take this minus up. So I'm having what? Minus into root 6 minus root 21 plus 2 root 2 minus 2 root 7 all over 5. This becomes my answer to this question here, as you can see. So this is like the idea behind addition and subtraction. Sorry. This is the concept behind multiplication and division of surds. Next class, we'll discuss about how to find the square root of a given surd. So next class, we'll discuss about that one much more better. Alright, if you found this class helpful, do well to like, share to your friends and classmates so they can learn too. And also do well to join our WhatsApp group. I'll be leaving the link to our WhatsApp group in the description of this video. So to join our WhatsApp group, simply check the description of this video. You'll see the link to our WhatsApp group. See you in our next class. Bye. Alright.